Chances are you've heard the word matrices in a movie, but do you know what they are or what they're used for? Well, matrices is plural of a matrix, and you can think about a matrix as just a table of numbers, and that's actually all it is. In other words, we can see it as an arrangement of numbers in columns and rows. They are the ones with square brackets around them. Matrices are used in many fields, ranging from linear equations to computer graphics, used to make this video, for example. Each number in a matrix is assigned to a row and a column, and the matrix itself is described by the number of rows and columns in it. For example, a matrix with 3 rows and 2 columns would be called a 3 by 2 matrix. This term is referred to as the dimensions of a matrix, so the matrix above dimensions are 3 by 2. Then what would a 2 by 7 matrix look like? Pause and think. Well, we know that the 2 tells us that there are 2 rows, and the 7 tells us there are 7 columns. Simple. Matrices are very often referred to with a capital letter. So for instance, we could call this 2 by 7 matrix we have below matrix M, and this 3 by 3 matrix, matrix C. Sometimes we write the dimensions of the matrix underneath the capital letter. We can also refer to individual numbers in each matrix by using the columns and rows to identify them. A number in a matrix is referred to as a matrix element. Each element corresponds to a row and a column. We'd refer to the element 1 in row 4 and column 3 of matrix B as B43. Which number represents B22 in matrix B? Pause and have a think. The answer is 11. In general, if the element is in row I and column J of matrix Z, it would be represented like this. Now it's your turn. Answer these 5 questions below. Pause the video while you think. Did you get them right? In our previous video, we have seen what matrices are and how we label them. However, in order to use them efficiently, we must first be able to carry out simple operations with them, which is what we will be exploring in this video. First up is addition. Here you can see 2 different pairs of matrices. The first one is made up of 2 similar ones, which means that they have the same number of rows and columns, while the second one isn't. A very important thing to understand is that in order to add up 2 matrices, they must be similar. Therefore, we can add up the first pair, but not the second. After we have made sure that the 2 have the same dimensions, we can then proceed with the actual addition, which is a simple and straightforward process. The rule dictates that we must add together the corresponding terms. What this means is that you just have to add up the elements in the first row and the first column of matrix A with the ones in the same position in matrix B. These elements will occupy the same position in the resulting matrix A plus B. Do the same until you have added together all the corresponding elements and placed the results in their correct position in the result matrix. It's important to notice that the result matrix will have the same dimensions as the 2 starting ones, which means the same number of rows and columns. We can do the same with subtraction, only pay attention to the signs that the elements of the result matrix will have. Some might be negative. The product of 2 matrices, on the other hand, is a little more complicated. Firstly, we can only multiply together 2 matrices if the number of columns of the first one is equal to the number of rows of the second one. Therefore, we can multiply together the first pair of matrices, but not the second. What we then have to do is a little trickier than the rest. We take the first element of the first row of matrix A and multiply it by the first element of the first column of matrix B. We then take the second and the third and do the same. After that, we add the results and place them in the first row, first column of the result matrix. We then move down and do the same for the second row of A and the first column of B, placing the results in the second row, first column of the result matrix. We do that with all the possible combinations of rows of A and columns of B, placing each result in the correct spot on the results matrix. We can then notice that the result matrix will have the same number of rows as A and the same number of columns as B. So, this is how you add and multiply matrices. However, before doing any operation, remember to always check whether or not you can add or multiply together the matrices you are working with, as that is usually the part that catches learners off guard.